So what I love about science is how imaginative it is. It's very creative. It's very rigorous, but it's also very creative. And what scientists tend to do a lot, and as many of you might know, is sort of run through things in your head. You write on paper, you type on your computer, you go on chalkboards, but there's also a lot of thought of experiments that are going on. You've probably done thought of experiments before. We're going to do a couple right now to flex our thought experiment muscles. Okay, so here's the first experiment we're going to do. I want you to imagine we're all sitting in a school bus. Okay? Got it? Sitting in a school bus, and we're probably going somewhere cool because we're all really fun. And and to entertain ourselves on the way there. Now we're sitting out front here, so we're just sitting in front of the bar. We're not going anywhere, but we're all just waiting, getting ready to go. And to keep ourselves entertained, we have a ball in our hand because it's fun to like play catch and stuff. And this is the experiment I want you to do in your head. You're sitting there, you throw the ball up. What happens to the ball? It comes back down. Okay, good. Because of? All right, okay, cool, awesome. So we're doing good. Okay, so fast forward, we're driving down the 417. Bus driver's got us going to our cool party, and bus driver says, okay, throw on cruise control. We're at 100 kilometers an hour. Everything's great. We're all still sitting there, waiting. We're driving down the highway at 100 kilometers an hour, exactly 100 kilometers an hour, and you take that ball in your hand and you throw it up. What happens to it?
So it stays there, but the bus moves. Yeah.
Oh, interesting. It comes back down. The ball's moving 100 kilometers an hour, you're moving 100 kilometers an hour. The ball's just going to go up, come back down, because your inertial reference frame is unaccelerated. The ball's not going to fly to the back of the bus. No. The bus and the ball and you are all moving at the same speed. Ball goes up, ball comes down, lands right in your hand, which is really useful for when you're on a bus and you're like standing and holding the pole and the bus is going at a speed and you like take a foot up, you won't go flying back. It's really useful. Okay, so that's experiment number one, okay? Let's extend this to light. Let's do a similar experiment, but with light. And for this, I'm going to need 2 volunteers. So I need 2 volunteers, hopefully close to the front, so that they don't have to like navigate through. So I need 2 people to come up here. Who wants to come up? I need 2 people. There's one. Okay, come on up. All right, cool. And I need one more. Come on. Yeah, there we go. Okay. All right. So you're gonna get the flashlight.
Okay.
Okay, you can just take a seat in this chair right here. And you're gonna get these 2 coasters. And I want you to hold the coasters like kind of like this. There you go. Okay. And I'm gonna I have a little space person here. Okay, so got a little lightsaber. And if you can you hold them hold the little astronaut?
Okay. Yep.
There we go. Okay, this experiment is going to be a photon clock. Okay, so these are 2 mirrors, mirror 1, mirror 2, and you're the light. Imagine we set up a beam of light that was bouncing from this mirror to this mirror. So your light is going to go bing, 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 trying to shine it in your eyes. Sorry. So you're going to illuminate this one, and then illuminate that one. Okay, perfect, and just keep going back and forth. Okay? So beam of light going back and forth, bing, 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 and we've tuned it perfectly so that it takes exactly 1 second to go from here to here. That's our thought experiment, okay? So 1 second, 2 seconds, 2, so give me 5 seconds. Perfect. There's our first thought experiment. Now, you in the crowd, you're measuring 5 seconds, and this little astronaut right here is also measuring 5 seconds. 1, 2, 3, 4, 5. Now let's see what happens when we get this apparatus moving. You are going to get put onto a rocket ship.
Cool.
And so let's start you over here. Cool. For free, totally. So come stand over here. Now we're going to do the same experiment, but I want you to just gently move to this side of the stage while you're still doing the 1, 2, 3, 4, 5. Okay? Let's go for it. Okay? 1, 2, yep. Keep going. There we go. Okay. Perfect. All right, experiment done. Now here's the interesting thing. The light for this astronaut, going 1, 2, 3, 4, 5, is traveling this far each time. This astronaut is sitting on that rocket ship. The light is going up and down, traveling this distance. But for you in the crowd, what distance is that light traveling? Let's do it one more time. Let's do it one more time. Come back onto this side. Now watch, if you were, as our spaceship moves across the stage, the light starts at this mirror, but as the rocket ship goes across, it has to make a diagonal movement to catch this one. So let's do it again. Now, as it's going across, it's a diagonal movement to catch this one. And that added distance makes something really interesting happen. It means that you measure a longer period of time for that light than this astronaut does. And as a result of that, someone who's moving quick experiences time going slower than you measure. And that is how you do thought experiments in physics and astronomy. And that's how we have something called special relativity, and a really cool guy named Albert Einstein did this whole thought experiment in his head and wrote some papers about it. Thanks for listening, everybody.
Yeah.